Today we are going to discuss about that trigonometric identities chapter. Okay, this trigonometric identities is the application of trigonometry, and identities means formulas. So for this chapter we have to remember few formulas. It has three main formulas. One is this one, that is this one is the first, sin square theta plus cos square theta equals to 1. From here we can take out the sin theta's value by shifting the cos theta as 1 minus cos square. So we can get cos square also 1 minus sin square. So from here if we need only sin, we can take out the sin theta also. Sin theta will be root over of 1 minus cos square. Same way from here we can take out cos theta also. It will be root over 1 minus sin square. As the square will remove from here, the square root will come. Second formula you have to remember this one, that is sec square theta minus tan square theta equals to 1. So sec square theta is 1 plus tan square theta. So if we need only sec, it will be root over of 1 plus tan square. Same way, if we take out tan square, it will be sec square theta minus 1. See, tan square theta when we are taking out, we are shifting the tan square theta this side, and this 1 will be coming this side. So it's coming tan square theta is equal to sec square theta minus 1. Same way, third formula we have to remember cos square theta minus cot square theta equals to 1. From here, if we need this cos square, this cot square will be shift here this side, so it will become 1 plus cot square theta. When we need cot, that time we are doing it like this way. This cos square theta and this 1 is shifted here, and this minus cot is shifted to that side, become positive cot square, and we write it in this way, that is cot square theta is equals to cos square theta minus 1. Hope you understood. Next we have to understand few more things, that we have tan theta. So tan theta, we know tan theta means sin theta by cos theta, and this tan theta, if we take this tan theta, means also 1 by cot theta. Same way, if we multiply this tan theta and cot theta, so it will become tan theta into cot theta, it will become 1. Same way, if we write sin theta, we know sin theta is equals to 1 by cosec theta, and we also know that cosec theta is equals to 1 by sin theta. So from this two we can get this cosec into sin by cross multiplying. Sin theta into cosec theta will be resulting 1. Same way, we know cos theta is equals to 1 by sec theta, and sec theta is equals to 1 by cos theta. So by cross multiplication of these two, we can get cos theta into sec theta is equals to 1. These are the formulas you have to remember to solve this chapter sum, that is trigonometric identities chapter sum. Now we will see the applications of these formulas, and we will try to solve the sums. Let's see how can we solve this sum. This is given 1 plus sin A by 1 minus sin A, and which is equals to, we have to prove tan A plus sec A. We know tan means sin by cos, and this sec means 1 by cos. So we will try to put, see what I mean to say here in the RHS, what we have? We have tan A plus sec A. So here we are getting down, if we split both the thing, like tan is sin by cos, and here sec we split, then we will get 1 by cos. So down both by splitting we are getting cos. So the factor is A or theta, it does not matter. So how we will do? Check this 1 plus sign and this 1 plus sign we have kept as down also 1 minus sign. Now this down one we need cos. So we'll multiply with its reciprocal. Actually it is not reciprocal, it is called conjugate. Conjugate means here 1 minus sign is there, no? We have to multiply with its opposite sign. So 1 plus sign A we have multiplied up. We have multiplied 1 plus sign A down also. This step is known as rationalization. This is called rationalization. So by rationalization if we do, so the down ones conjugate will multiply up and down. That means denominators. So we'll get 1 plus sin A, here also 1 plus sin A. So this 1 plus sin A and this 1 plus sin A will be 1 plus sin A whole square. And down 1 minus sin A and 1 plus sin A. So A plus B and A minus B formula will be there. So it will be A square minus B square. That means 1 square minus sin square A. So this 1 plus sin square A up, it will be there as it is. Here 1 minus sin square A means cos square A. Now if we remove the root, this root over will be removed, but both are having square inside. Now after removing that square root, we will be getting 1 plus sin A up and cos A down. Now we will be doing separation of the each term by each term. That means this 1 by cos A and this sin A by cos A. Check, already we have here 1 by cos and here sin by cos. So we got 1 by cos means sec and sin by cos means tan. So we got the RHS. So we'll write RHS, hence proved. Let's see the second sum. How can we do it? Second sum was given like this. So we have root over 1 minus cos A by 1 plus cos A. We need this one equals to RHS cosec minus quat. Same way we have done the rationalization of the denominator. Here denominator is 1 plus cos A. So with the 1 minus cos A we have multiplied up and down. We got 1 minus cos A's whole square up and 1 plus cos A and 1 minus cos A. So A plus B formula is square minus B square here. So 1 minus cos square down, that means sin square will get down, and up same 1 minus cos whole square. So square root remove, we got 1 minus cos A by sin A. So we will split it. We have splitted it as 1 by sin. This cos by sin we have split it here. 1 by sin means cosec. This means quat. So we got the RHS. So let's see how can we solve this sum. This can be rationalized here also in this one and this one, but we'll try to do it in another way. So what we can do? Check. At first this LHS part will split. This LHS part, okay. So this RHS part we are not going to split it. So first step what we'll do, we'll split this root over this numerator and denominator separately. So up we are writing this sec A minus 1 and down we are writing root over, because the total thing is given under the root, so we can separate it. Here also we are separating it. Now what we will do, we'll do the LCM. If we do the LCM, down we will be getting as sec A plus 1, and for this and for this we are getting sec A minus 1. Now here the denominator is sec A plus 1, so this will cancel and this side will be multiplied with this, so it will be sec A minus 1, and if we multiply this side also, this with this, it will be one more time sec a minus 1. Directly also you can make sec a minus 1 whole square. Same way this side, this sec a minus 1 is there, that means this one is there, so we'll be multiplying with this quantity here. It will be, or you can say this with this also, it will be sec a plus 1, again sec a plus 1, so under the root, so we can make sec a plus 1 whole square also in a same step, though we are going to do it in here next step. So sec a plus 1. So what we got here, also we got sec a minus 1, sec a minus 1, it will be sec a minus 1 whole square. As the root is there, if we make it whole square, the root over will remove, so we are going to get only sec a minus 1, because this sec a minus 1 and sec a minus 1 under the root, 2 times multiplication, root will remove. Here also same thing, this sec a plus 1 and this sec a plus 1 will be under the root and multiplied, so root over will be removed. As we know, root over 2 and to root over 2 if we multiply, we are getting only 2. So we are going to get here sec a plus 1, and this minus 1 and plus 1 will be cancelled each other, and down we are getting under the root sec a minus 1 and sec a plus 1. So we will be converting it into the same root. We are going to get here sec a plus 1 and sec a minus 1. Now in the next step, what we are going to do, this sec a and this one will make it 2 times, and here down a plus b, a minus b formula, a plus b, a minus b, so a square minus b square. So under the root we are going to get a square minus b square, and we have a formula, that is sec a square theta minus tan square theta equals to 1, we have seen at the beginning. So from here, if we take out this sec a square theta minus 1, this tan square will be, that side will become tan square theta. So we are going to use this formula here. So we are going to get 2 sec a by under the root tan square a. So under the root, if tan square a we are going to get, tan a will be come out. So this is sec a by tan a, and if we split it 2 into, we know sec means 1 by cos, and this tan means sin by cos. So sin sec a we have split it in this way, and tan a we have split it in this way. So what will happen here, this cos a and this cos a will be cancelled each other. So we are going to get 2 into up 1 and down sin a. So we got 2, 1 by sin means cosec, and that was our RHS. So we have proved. Check that one only, our RHS 2 sec a. Here 2 sec a, we required 2 sec a, and we have proved also the answer as 2 sec a. So hope you understood. Try the next sum. Let's see how can we solve this one. Is given as LHS, this side cos a into cot a by 1 minus sin a. So from here we are trying to reach the RHS. Let's see. So starting from LHS. First step, what we are going to do, this cos a we are keeping. This quat is splitting it. We know quat means cos by sine, and down this 1 minus sine A is here, we are keeping it. Now what we are doing, this upper one cos into cos will be cos A square A, and down this 1 minus sine A into sine A, all we are keeping. We know cos A square A means 1 minus sine square A. We have a formula at the beginning, that time we have seen this. So down 1 minus sine A is there into sine A. Now here this 1 means 1 square. So up here A square minus B square, A square minus B square formula you can put, and the formula is A plus B into A minus B. So you can write one plus sine A as A plus B, and 1 minus sine A as A minus B. Down 1 minus sine A is here into sine A. This 1 minus sine A will be cancel each other. Whatever we have, we will write each term by each term. That means this 1 by the down sine A plus this sine A and this sine A. We can separate the terms as denominator is single. So this will be cancelled. We'll get 1, and 1 by sine here. This 1 by sine means cosec. So we got cosec A plus this sine A cancelled. We got 1. So this is only our RHS, 1 plus cosec A. So we got our RHS. This is our RHS. Right, hence proved. Let's see how can we do this sum. Here also we'll start with LHS, this side. So LHS is this one. Next step we'll be doing LCM. If we do the LCM, we'll get sine A into cos A as LCM. As sine A we got here, sine A cancel this, so this cos A we are going to multiply this side. So we're going to get cos A into 1 plus tan A, and this side next cos A and cos A cancel, so sine A will be multiplied here both with this. So it will be sine A into 1 plus cot A. Now what we'll do, this cos A will keep, or we'll multiply this cos A with both the term, cos A into 1 and this cos A with this next. It will be cos A into tan A. Same thing we'll be doing with the second case. Here also we'll multiply sine A into 1. So it will be sine A, and here sine A into cot A. This is cot. Down no change. That is sine A into cos A. Now this cos A will keep, this one cos A will keep, this tan means sine A by cos we know. Same way here, this sine A will keep. Next this sine A also we are keeping. Next cot is here, so cot means we know cos A by sine A. Down no changes. Sin A into cos A. Now what we'll get here, this cos A and cos A cancel, sin A into this down sin A cancel. So what we got? We got here cos A, this, and here only sin A, here one more sin A, here one more cos A. Check, this is this one, this sin A is this sin A is this cos A is here, down sin A into cos A. This cos and this cos are like term, so they are having 2 times, so you can write 2 times cos A. This sin A and this sin A also like term, so you will be getting 2 sin A. So what we can do, this 2 and this 2 you can take common and put it in the bracket. So you can write cos A plus this sin A. Two times each was that, 2 we have taken common, and down it is there sin A into cos A. Now we will be doing each term by each term. That means this 2 will be here out, this cos A is down, this denominator total sin A into cos A, here with this sin A the denominator total, that is sin A by sin A into cos A. This cancel, this and this one will be cancelled, so 2 into here 1 by sin, and 1 by sin means cosec, and here 1 left, so 1 by cos means sec, and that is only your RHS. So got the RHS, you can write hence proved. Hope you understood this sum.